This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We're diving into an interactive learning tool, the Cat and Dog Kinematics Graphs JavaScript Simulation Applet. It's a fascinating example of how technology can enhance education.
Indeed, this applet offers a dynamic way to graph complex kinematic concepts. It moves beyond static textbook examples.
Exactly. Instead of just reading about displacement, velocity, and acceleration, students can actually manipulate the variables and see the results in real time.
The visual representation through graphs is key. It makes abstract ideas concrete and easier to understand.
And it's all done through a user-friendly interface built using HTML5, making it accessible across various devices. Let's start with a general overview of the applet. What are its core features and functionalities?
The applet simulates the motion of a cat and a dog. Users can drag these characters to set their initial positions, influencing their subsequent movement. They can then observe the resulting position time, velocity time, and acceleration time graphs.
It's not just about watching pre-programmed motion. Students actively participate in shaping the simulation.
Precisely. The interactive nature allows for experimentation and exploration. Students can change initial conditions and immediately see how those changes affect the motion and the corresponding graphs. There are also play/pause, step, and reset buttons for fine-grained control.
Who is the intended audience for this applet?
Primarily, it targets students learning kinematics, but it's also a valuable resource for teachers. The applet's design facilitates interactive learning, allowing teachers to guide students through various scenarios and reinforce key concepts.
And what are some of the explicit learning goals?
The goal is to foster a deeper understanding of kinematics by visualizing the relationships between position, velocity, and acceleration. The interactive nature helps students connect abstract concepts to concrete examples, improving comprehension and retention.
You mentioned HTML5. Why is that significant in the context of this applet?
HTML5 ensures broad accessibility. The applet runs smoothly in most modern web browsers without requiring any plugins, unlike older technologies like Flash. This makes it readily available to a wider range of students and educators.
And what about the technical aspects of its creation?
It's built using JavaScript and HTML5, making it relatively lightweight and easy to embed in web pages using an iframe. The credits mention Fukun Huang as the creator, with remixing contributions from others.
Are there any known limitations or potential issues with the applet?
The documentation mentions a minor bug related to excessive toggling of view checkboxes. This is something the developers are likely aware of and may address in future updates.
What improvements or additions could enhance the applet further?
Adding more complex scenarios, perhaps involving forces or different types of motion, could expand its educational value. More detailed explanations and interactive quizzes could also be beneficial.
And the applet is part of the Open Educational Resources/Open Source Physics at Singapore project. What does that mean?
It means the applet is freely accessible and openly licensed under Creative Commons, allowing for reuse, adaptation, and sharing. This aligns with the broader OER movement, promoting equitable access to quality educational materials.
How does this open source nature benefit educators and students?
It removes financial barriers to access, allowing educators worldwide to utilize the applet in their classrooms. The open source aspect also encourages collaboration and improvement, leading to a constantly evolving and enhanced resource.
How does this interactive simulation compare to traditional lecture-based methods of teaching kinematics?
Interactive simulations offer a more engaging and effective learning experience. Students are actively involved in the learning process, leading to better understanding and retention compared to passive listening.
Can you elaborate on the advantages of this active learning approach?
Active learning allowed students to experiment, make mistakes, and learn from those mistakes in a safe environment. This hands-on approach fosters deeper understanding and problem-solving skills.
How can the principles of kinematics, as illustrated by this applet, be applied to real-world scenarios?
Kinematics is fundamental to understanding motion in various fields, from sports and transportation to aerospace engineering. Analyzing projectile motion, for example, is crucial in sports like basketball or baseball.
Okay, gives a specific example.
Understanding the trajectory of a ball in basketball involves applying kinematic principles to predict its path and optimize the shot. Similarly, in transportation, kinematics helps in designing safer and more efficient vehicles.
The accompanying study guide includes a quiz. What's the purpose of this quiz?
The quiz serves as a self-assessment tool, allowing students to test their understanding of the concepts covered in the simulation. It reinforces learning and identifies areas where further study might be needed.
What types of questions are included?
The quiz includes short answer questions to assess basic understanding and essay questions to encourage deeper reflection and application of the concepts. The answer key provides immediate feedback, facilitating self-directed learning.
The briefing document provides a comprehensive overview of the applet. What key information does it convey?
The briefing document details the applet's features, functionality, target audience, technical specifications, and licensing information. It also highlights potential issues and suggests areas for improvement.
Why is this document important?
It serves as a valuable resource for educators and developers, providing all the necessary information to understand and utilize the applet effectively. It also facilitates collaboration and further development of the resource.
The provided FAQ addresses common questions about the applet. What are some of the key questions it answers?
The FAQ clarifies the applet's purpose, accessibility, controls, creators, and learning goals. It also addresses the licensing and potential bugs.
How does FAQ contribute to the overall usability of the applet?
The FAQ provides quick answers to frequently asked questions, making the applet more user-friendly and accessible to a wider audience. It reduces the need for extensive searching for information.
The materials mention the Easy JavaScript Simulations library. What role does it play?
The Easy JavaScript Simulations library is likely the framework or set of tools used to build the applet. It provides the underlying functionality for creating interactive simulations.
And what are licensing for commercial use of this library?
Commercial use requires separate licensing through the University of Murcia, as explicitly stated in the provided materials. In conclusion, the Cat and Dog Kinematics Graphs JavaScript Simulation Applet is a valuable educational tool that effectively leverages technology to enhance learning. Its interactive nature, accessibility, and open-source licensing make it a powerful resource for educators and students alike.
That was a great discussion. Thank you for sharing your expertise.